So we have studied that part, this filtering signal processing. We can do it using our embedded system, which is an alternative approach for approach. Okay. Okay. Before I go with today's topic, I want you to ask that the quiz, there will be a quiz, and those quiz will be surprise quiz. The day I will take, the same day I will announce, and I will immediately take. Okay. And there might be a series of such quizzes. And unless and until you have you are attending these classes, it will be very difficult for you to answer. Not only that, the weightage of the quizzes will also be more in that. Okay. So I expect that you will be sincere enough while you are attending these classes. Otherwise, you may fail also. So you should be careful. Okay. So
Yes, sir.
now, our next topic is that embedded system design. What should be our approach, and what are the situations happens in industry, and how we start the design methodology. Now, definitely, our system design is will be correlated with what a client or customer wants to solve any particular problem. And now very often the customers are not very technical in nature. And so what they will do, they will provide us some statement which are very fuzzy in nature and which are with the layman's language. And so as an engineer, what we need to do to convert those non-specific terms into specific one and technical one. So our design approach starts with the requirement analysis, and this after going through the client or customer's requirement, we should find that what way we can solve it. So we should convert that statement into technical specifications. Once that is carried out, then we go for selections of the embedded processor and circuit components. Now here we are for this course to be time bound or so, we are only concerned about 8085 and 8051. But you are free to choose as an engineer in industry, free to choose any processor where you or your team members may be adept at or expert at. And you can you also need to know about the electronic circuit and its analysis so that your circuit always gives you the correct output or so. So anyway, so you are free to choose this embedded processor and you can do it. And now you have to design or place your circuitry. So we will have two approaches in that system designs. Once we do this process, what we can do, we can go with system integration or simulation. So our approach first is simulation. And for that, as we have said, that for microprocessor, this 8085 will have some simulator, and also for 8051 will have this called Proteus. Okay. So where we'll be connecting means we'll connect our circuits components, and then we'll code. We write our code in assembly language, and then we'll check whether that output is meeting the customer requirement or not. And then once we satisfied with this result, we'll go for hardware implementation and again testing. Now, this testing is not so easy and may take long time. Okay. But this time may be reduced with experience. So as you grow your experience, your testing time may come down. Else you need to put a lot of time for that. So, and not only that, you should also be aware that while your circuit is working in the simulation mode, it may not work in the actual hardware. Okay. And there are a lot of reasons, and very often that may be non-technical in nature also. Sometimes it may be as minute as like say dry soldering problem in your PCB or something like that. So that's why unless you grow your experience, this may take longer time. Now, while you can see from in this right hand side picture, so we can start with requirement. So from the general requirement, and then we are going towards the specific technically specific design. And we call that as a top down approach. Now, there is another approach and which we can call it as a bottom up design, and that is that as a firm, engineering firm, you can have already developed some components or some algorithm or some codes which can be reused. And so once you learn about the general requirement, you can start from connecting or integrating all those components and then making an architecture make and finding the specifications and then ultimately testing that whether again it is meeting the customer's requirement or not. So in that case, it is bottom up design. But overall, what we can learn from this is that while we are starting the project, we may go with this top down design. And while we'll be testing our circuit, we'll be utilizing this bottom up and finally check whether it is meeting the goal of the customer or not. And we can also start from bottom up if we have already gained a lot of experiences and lot of resources are available with us and which we can intelligently integrate and make our required system and convince our customer also that this system will actually fulfill their goal. Now, to have an understanding that how customers' statement can be, so we can, I have written one such statement that they are telling we are color painting company and we need to measure the area of walls to be painted all the time. Okay. And measuring tape is not useful as we may not be able to reach to the ceiling or rooftop. Okay. So we need a distance measuring device that can measure it remotely, like standing on the floor. Only will be able to measure the height of a room. Okay. So then if we can measure the height of a room and also the width of the room, we can easily measure the area of that wall or number of walls. And so this is very non-specific problem, only that goal is given to you. And now I ask you, maybe you can come up with different ideas that what could be a possible solution. So one by one, or one of you start and then I will ask some of you. Okay. So
Sir, sir, we can
uh,
either use ultrasonic waves to detect the distance or infrared sensors.
okay, this is Anshuman Raghuvangshi, right?
Yes.
Okay. Okay, this is one possible solution. Any other solutions? Is there any other solutions possible? So Sahil Kumar Naik,
Yes, sir.
tell me if you can guess or something like that. You can provide some ideas.
Hmm. Sir, by
Hmm.
sphygmomanometer.
Sphygmomanometer.
Yes, sir.
What is sphygmomanometer?
Sir, means by using Pythagoras theorem and all, we can calculate the height of the rooftops and angle of elevation.
But is that called sphygmomanometer?
Sorry, sir, I didn't remember the name of instrument.
But sphygmomanometer is there where it is used generally.
Sorry, sir.
That is for pressure measurement instrument, right?
Yes, sir.
Hmm. No, but what is our target here? That we need to think that how we can utilize a digital system or the embedded system, right? So we have already shown you that the system architecture in overall architecture, that it should get the signal through ADC, then it process or compute inside the processor, and then it produce the output. Now, depending upon the requirement, either we can take the digital output directly or we can go through the DAC. So here, while we are analyzing the customer's requirement and why we should, means though it's an alternative, why we should think that it should be only digital solution. This is means one point we need to think that in which way we are skilled enough. So if we are skilled with the design of digital systems, so our team is also adept at that. So in that case, we'll be thinking with this. Okay. So that's why our approach here is to think with that. So we need to have a signal, and then that signal should be processed. And once this is processed, we can come up with this measured value of distance. Okay. So anyone else, this what is his name again? I think Anshuman, but he is your seer.
Yes, sir.
Tell.
No, sir, like I had what Ayushman had said, like the ultrasonic one that only I was thinking of,
Hmm.
like that
But
can be
in
one
any
effective
kind of
thing.
light signal or so, visual light or laser, or I mean, so whether possible or not.
Okay, sir, I'm thinking in that
Okay,
direction.
okay, okay. You think? Let me ask other people. Shamir Ranjan Shahu.
Yes, sir, the same thing, the
Hmm.
digital height meter kind of thing.
No,
Like it,
actually, again, I will insist you to come up with different sensors. Okay, because that is the place, or not only that place, but also with different processors or so. But now at this moment, we are constraining that processor type. So if you can change the sensor, so that way you can be different from, or your solution would be different from your friend's solution. Okay, that
okay,
is
so I'm
also
thinking,
necessary. That is also necessary because during the exam also I will ask you to have different solution. So any common solutions will not be marked properly or reduced. Hmm. So you should come up with that solution. So maybe you can come up with later also, not that means you will be doing now only. But I want to know if you can do it now also. Hmm. Hiranmay Mohanto. Yes, Shweta
I
Das.
was also thinking like that.
Okay. Shweta Das.
Sir,
Sir,
can
I
we
was
use
thinking
augmented reality to find the dimension? Like uh, we can visualize the wall and into reduced dimension, and then we can estimate it. Like, can we do in such way?
Uh, okay, you see, means what should be an engineering solution? Okay, you may learn many things, but the solutions which will sustain and it will provide customer satisfaction, which is meeting their goal at the same time it is cost effective. Okay, and
Yes, sir.
if your
I
system
will,
becomes costly, then probably your product is not going to sustain in the market for long. So that part you also need to be concerned about. Yes, Shamira, I am coming. Shweta, you have something to say.
Sir, I was thinking we can use IR sensors.
Okay,
They,
good. Good.
yeah,
Tell.
we can measure the distance by it sends a IR signal and it receives it back, so we can measure the distance using that.
Very good. Very good. Very good. Then, okay, Ahan, Anupam.
So yes, sir. Sir, you said that we can use light. So in that way, I think that we can use if there's sunlight, then we can make use of the sunlight. I mean, there's the concept of angle of incidence. I mean, the sunlight will make an angle with the ground. I mean, the shadow, right? So we can use something
No,
like a
no, no, no,
photodiode.
okay, Ahan, you have to think very pragmatically, right?
Sir, can we use
That
a laser light
this
to?
this is a painting task on the wall, and within a house, you are not going to get the sunlight, right? For a particular wall,
Okay, sir.
may not be there. Hmm? So then it is not going to help us. Hmm?
So yes, so the
Okay.
first solution I
Uh,
thought was the ultrasonic one only. This
Sir,
was the second.
hmm. Who is telling?
sir, Nitin.
Okay, tell.
Sir, we can use laser light to measure the angle at which the top of the roof is pointing, and then we can use tan theta.
Okay. So I will insist, rather you can take it as an assignment also, right? You come up with a digital circuit. We'll decide this processor later on, but at least you can draw the circuit by yourself with a preliminary idea of the mechanism of your circuit operation. Okay. So those who are providing the solutions and not those whom I am not be able to ask also means with this time. So everybody should do this problem that first you draw a circuit and decide about the sensor and then draw your circuit by pen and paper, not any software or so. This is I'm insisting so that it will be registered in your brain. Okay, so it should not be on the software. You need to draw it on pen and paper and then you submit as a JPJ in the MS Team. I will provide that link also later on. Okay, so someone, Shamir, you wanted to say something? Shamir Ranjan Shahu?
No, sir, the same thing. The ultrasonic sound thing. Yeah. Nitin said
Okay.
that. I think.
Hmm. Okay, another one who had raised his hand, Sharup, I
Yes,
think.
sir. Yes, sir.
Tell.
Yes, sir. I was thinking that we can use a device
who contain a transmitter and a receiver, and we can send any light signal, and at the transmitter end we can check the timings, and obviously we know the speed of the signal we send, and we can calculate the distance from that.
Acha, what about the power supply to this device would be?
It should be minimum, means.
No, I'm not talking about the minimum, the source. Anyone can answer. Tell.
The device that we are using to check this, the power source of that device.
Yes. So as per customer's requirement, can we understand that? So they want to measure the area of the walls. Now, where they want to measure? Any house, any arbitrarily locations, right?
Yes, sir.
Yes, sir.
Yes.
And therefore, there is a chance that the power may not be available. Say, the coloring can be done also some remote places, remote villages, or where the electricity is not there. Right? And therefore, and also the system should be portable enough, right? So that they can take with them and measure at any locations, any places. And so it must be battery operated.
Yes, sir.
Now,
DC.
so once, DC, your digital system will be DC. Your microcontroller or microprocessor supply is DC only. But it is battery operated. Now, we can have different ways to supply the power in our digital system. One is we can get it from directly AC, but through adapter. We'll be rectifying, then we'll be putting these voltage regulators, and then we'll supply that. So in between, we can have a transformer in certain cases. In certain cases, we have transformer less adapter where we may use these capacity based circuits. Okay. But in both the cases, we need to have a connections of the power supply, the domestic power supply, AC. But in case of battery power supply, one major concern is our circuit operation must be as minimum as possible. Okay. And then we'll see just after one or two slides that this is a major concern when we are talking about low power application, because the battery should also go for longer time. Otherwise, the running cost will be more and people will be not interested in this product. Right. So we understood that where we have freedom, that choice of sensors and then mechanism of those sensors. So how to get that signal. Now that signal in general, you have this analog in nature. So we can take this ADC to get our digital signal. Once we get the digital signal, we can go through with some computation. And our target is always to have less number of computations. Now, why less number of computations? Can you tell? Abhijit Nayak.
Yes, sir.
In
Sir,
case of
sir,
battery operated system.
sir, before I answer this, can I answer the previous one like you were asking about what can be the ways of measuring the area?
That's fine. You can answer definitely.
Sir, I have seen like an instrument which uses like a clock pulse
Mm,
to measure a particular it will send a photon of light, a small amount of
mm,
photon of light, and
mm,
it will reflect from the surface and it will measure the time taken, the average time taken.
mm,
From that, it digitally shows the length from where it was projected. So if we put it
mm,
on the floor and activate that, we can get the height as well
mm,
as we can choose any side walls so that we can
mm,
get the length and
mm.
eventually we'll get the area of any walls.
Okay, that you have seen.
Yes, sir. It's
Uh,
actually used for measuring feces in the ocean because you can
mm.
just go and measure the whales and all. So they measure in this way.
No, but you also need to tell that in which band that light lies, the frequency.
So that I
Is
have
that is it in visible range?
no, sir, not visible.
Uh,
That one I know not visible, but
uh.
exactly I
But
don't know.
okay, means probably this particular problem may stimulate you and to for finding that answer. So you want find it in between. Okay,
Okay, sir.
means not today, but you can find, and then you can come up with the means very refined answer. Huh? That would be
Okay, sir.
very good. Uh, and the second question I asked that in case of battery operated system, I am telling the computation number of computation must be as minimum as possible. Now, why it is
Yes.
so?
So that we can work with with a single charge for a longer period of time, and accuracy also matters. So let's
So, com
say
so
if a
every
particular circuit.
computation will consume some energy,
Yes, sir,
right?
and there will be some error. So error handling also consumes some energy. So
Hmm,
for more period of time of
hmm,
usage, we need to have minimum number of components.
hmm, hmm. Okay, not minimum number of components. That is okay. That is fine. And now we are only talking about minimum number of computations. Okay.
Okay, sir.
So, okay. So now, once we understood, so I think this gives you some understanding that how we can have customers problem statement, and then how we can come up with a solution in particularly in our domain. And it not only requires the knowledge of the only 8085 or 51 or digital processors, but also the electronic circuit analysis is necessary. So digital electronics is also necessary, and that part I will keep on you. Means you what means whatever required for digital electronics part, you need to read separately, and you may have to give more effort onto that. Okay, so while we are talking about the technical specifications or so, we must have some design goal. And here I am giving you some way to think that what could be those possible goals and how we could mitigate or get those goals met. So first we are talking about that to optimize the hardware resource utilization. So that is related to first is cost. So the cost, if we can reduce, the product in the market can be sustained for longer period. So that is one good reason that we need to do that. Then how we can achieve that one? So when we are having this say memory, so when will be developing our code in 8085 or 8051 or any digital processor, we'll see that every processor is having a certain amount of memory, either within the processor itself or outside the processor. And that you can easily observe from your computer system that you have a hierarchy of memories. So inside the processor, which memory resides, that is the fastest processor, but its size is very less. The more your memory speed is available, the cost of that memory is also more. And therefore, what is need means people have come up with this hierarchy of memory so that we can have a low speed memory with low cost, but it should be at the this size of that memory could be bigger. Okay. And then we can have, so say for example, like I could give that hard disks, what you have in your computer, that is the slowest memory, while a little bit faster is your RAM memory. Then little bit faster from compared to RAM is your cache memories, which is within your motherboard. And then you have again some memory within the processor itself or closer to that processor in this case, because in your computer system, it is the microprocessor, not the microcontroller. So memory is not inbuilt into it. But the closest to the processor will have the fastest one, but it will have smallest size of the memory. Okay, because of the cost effectiveness or so. Now, so what we need to develop an algorithm which will interact with memory as less as possible. So we need to optimize, and we cannot compromise also that means we may need say 1 kilobyte of memory or 2 kilobytes of memory or 4 kilobytes of memory, and if any particular algorithm cannot be accommodated within that, what is needed, we need to change the algorithm itself. And what is algorithm? It's a different alternative approaches to solve a same problem. And this is possible. You can have also some examples from your computer architecture knowledge or algorithm data structure also, I think, where you could find that there are number of algorithms for searching a particular number or pattern or arranging different numbers in ascending or descending orders or so. So many people have come up with different solutions, and each of the solutions will have means they have some pros and cons. And so we can come up with different algorithm, and whichever is optimized with respect to say memory, we can take that particular algorithm for this solution. Now, in case of digital circuits, and particularly, I have highlighted last time that there is currently in embedded system, one processing units are available, which is dependent on the FPGA, field programmable gate array. So there actually we can develop number of digital circuits inside those chips. And from your digital electronics background, or you can know that we can actually simplify different Boolean algebraic equations for the circuits and so we can reduce the size of the circuits, and thereby we can optimize the hardware resource utilization, and this will indirectly impact on the cost of the system development. Now we want to optimize the power consumption of the system. Okay, so because as we just highlighted that we can have a portable system, so battery operated, and the user wants that battery should last for long period of time. And so what we can do, how we can reduce these power consumptions in our development. So we can develop an RTOS, which we can call it as a real-time operating system. And this RTOS, what it will do, it will optimally utilize the resources available inside the chip, the memory or different components interfacing this also, this particular processor, in such a way that the power consumptions will be very less. That means the memory interactions could be less with the help of this. So RTOS basically manages these resource utilizations. And if means while we'll be going through the different ways of coding and this developing this assembly code, we'll see that we can have some devices which are interrupt driven and some devices which are polling based methods, follows the polling based methods. Now this interrupt driven, so how what are those? Okay, so now for example, that one of your friend is very good at particular subject, but he doesn't want to be interrupted by his friend or her friend during the exams. Okay, and but he has some helping attitude also. So he is telling that don't disturb me all the times. Whenever you are requiring some, you are facing some problem, only that time you can come to my room and you can get the solution. So now you replace your friend by the processor, and the other friends which are requiring the solutions. So they are the devices, peripheral devices, and then they are interacting in whenever that particular student is facing that problem. Otherwise, he will disturb his friend. Another way is that your friend may be very philanthropic in nature and he wants to help everybody, but he will give some slots to everybody. So say friend one, friend two, friend three, like that. And then he will go to friend one, try to solve his problem. Then once this is over, then he can do his own work. Then after some time, he will go to friend two and then friend three. And then again, he will check whether friend one is okay or not with his or her problem. So this method of servicing we'll be calling as a polling methods. So similar thing happens with our digital systems and particularly this embedded system, that the processor is servicing every different task with a given time slot periodically, which we'll be calling as polling methods. Or the device will be connected to the processor. Whenever it needs some service by the processor, then only it will give some request to the processor that we need service, and then processor will provide the service to that particular device. And the remaining time, it will keep, the processor will be busy with its own work. Now, with this way of utilizing these modes with the help of this operating system, the activity can be optimized, and so the power consumptions can be optimized. Now we can also use some simplified circuit or efficient placement. This placement is particularly important when we are designing our circuit for a, say, distributed way. Okay, so in the PCB also, if we keep two devices which are communicating far apart, then the time requirement, the power requirement to communicate through that wire channel, this PCB base, so that will be more. And so if we keep them closer, so then the power requirement will be less in that case. So that efficient placement or routing or using the simplified circuit, we can reduce the power. The third point is by optimizing the clock speed of the processor and meeting real-time constraint. Now, here we have to critically understand that why this clock speed is important and optimization of clock speed is important. Now, you see that what is the clock? Clock is basically a scale of time which is constantly given to the processor so that it can maintain that at what time a particular task should be obtained. So it will give you the reference of the processor, the reference of the time, instance of time. Now we generally use a crystal clock and say tentative value or typical value is say 12 megahertz, 4 megahertz, 24 megahertz, and so on. Now, what will happen if I increase the clock speed? That means instead of taking 4 megahertz as a clock, if I take 24 megahertz, what will happen to the processor and its activities? Now, we can have some analogy with, say, for example, heartbeat. Okay, so the heartbeat, what it does for our human body, this similar thing happens, or similarly, this clock does with these processors, digital processors. Now imagine a situation that you are running, okay, and
Sir, the
yes,
slide is not changed. Like it's still on
I
first and
have not
second.
changed. I have not changed.
Yes, sir.
Okay, this is,
Yes, sir.
you can see it is with the second point and then with the dot third point by optimizing clock speed.
Yes, sir. But
Yes, I have not changed it. Just a minute. Has it changed
no, sir.
now?
It's fine. It's fine. There was
Ah,
a small confusion from my side. Sorry, sir.
okay. So what I was talking about, that heartbeats are analogous to the clock of the digital processor. Okay. Now imagine a situation you are running, and at that time, if you measure your heartbeat, what it will be, whether it will be higher or lower.
Higher.
And you higher. Okay. What about your energy consumption during that time?
Higher.
Why it is so? Because every clock cycle, so say for example, every positive clock edge, and what is meant by positive clock edge? We have these clocks like this signal, and so every positive clock edge, some activity happens. Now I have increased the clock speed, so now the number of positive clock edge with respect to same time interval is getting increased, right? And so at every positive clock edge, say, some activities are happening. Now in this case, what we are finding? We are finding only two activities. In this case, we are finding just double number of activities, okay? And therefore, what we can find from here, that if the clock speed becomes more increased, the number of activity also becomes more, and thus it requires more energy to do serve the same purpose, though it will be becoming a faster. And this is actually happens in our human body also, with this heartbeat increased or decreased or so. So whenever you are at rest, you require less energy. Whenever you are running or doing some actions, you require more energy. And that time, if you observe your heartbeat, that is changing. It is not fixed always. Okay. And so in case of digital system, what we need to have, that we need to have an optimized clock. So it means that it is not necessary that always we should go for higher clock speed just for the sake of making it faster. Okay. So if we are not thinking about the other concerns, so that means if your clock speed is higher, it is highly likely that you will not be able to develop a portable battery operated efficient system. Okay. Now question is that if we reduce the clock speed, then can we meet the customer's requirement, the real-time operations? So we'll come to that real-time operations, understanding of that. But for the time being, we are understanding here that our clock speed should not be arbitrarily high, and it should not also be arbitrarily low, and it should be in between, some optimized one, so that we can make some design for battery operated system also. Now we can also develop algorithms with reduced number of activities. So algorithms are nothing but a sequence of actions. And so if we can, so that means we can change the algorithm itself to serve the same process. Now we need to meet the timing constraint for the concerned application. Okay. So sometimes we can, like this, as I said just now, that this clock speed can be reduced, and with that clock speed also, if we can find that our system can be concurrently operated or parallelly operated, so then at a time multiple tasks can be done, and then we can come up with the meeting of the time constraint. Or we can also go with time efficient algorithm. Very often we'll be utilizing the term called time multiplexing. Okay. Multiplexing of different activities in the time scale. So which I have said to you, like this, using this interrupt driven method or polling methods or so. Then this part is also important, that our computation should be accurate and precise. Now, by use of efficient representation of number and corresponding arithmetic. Now, by that, if you recollect your yesterday's lecture, you can see that we have come up with different forms of number representations like integer, okay, then fixed point, and then floating point. And here also we had discussed that this integer takes less time to compute, but it is highly inaccurate. Fixed point is moderate, and floating point is taking higher size of the memory, slowest operations. And so depending upon the timing and other constraint, again the floating point activity number of activity of computations will be more compared to fixed point one. So in some cases, whenever we find okay, battery operated but accuracy should also be maintained, we can go with the fixed point representation instead of floating point or so, right? And but certain cases it may happen that the precision or accuracy what is required, that can be achieved by the integer computation. So then we can go with the integer computations. So it is not mandatory that we have to go for only floating point or only fixed point or so. It completely depends on what are the requirements by the customer or the user. Okay. Then we can increase the bus resolutions optimally. Now, bus resolution means that the number of labels in the digitizations. Okay, so say number of bits to represent the whole range of the signal that we are dealing with. Say, for example, 0 to 5 volt. And so I can take, say, 3 bits. I can take, say, 4 bits, or I can take, say, 8 bits or 16 bits, okay, and so on. But as we are growing our number of bits, we can also be sure that this is going to increase the cost of the system. So that means accordingly we need to choose the processor. So 16-bit processor or 32-bit processor, and accordingly my overall system cost will also be increased. So that we should also take care. We can minimize the space or area in case of, say, distributed system. Okay, and then this is another important issue here. As an embedded system engineer, you should always keep some provision for future requirement or future augmentations. Okay, if you do not do that, what will happen? Can anyone guess? why we need these future requirement provisions. Who can tell? Amarjit Pani.
Yes, sir.
Tell me. Amanjit, sorry. Amanjit Pani.
Yes, sir.
Hmm? What are you doing?
Sir, I'm listening.
Hmm? So answer. What question I have asked you?
Sir, I've asked, why do we need a future requirements provision for a system?
Okay. So what is your answer?
I don't know.
You don't know.
Yes.
But for that, actually, you don't need to read anything. You are using your mobiles
Yes,
or
sir.
not?
Yes, sir.
So as an user, what you want? The features which are available today, tomorrow, one. I'm not asking very specific to that, but you can generally speak.
Sir, we want that we can use it for a longer period of time.
No. Say you have purchased a mobile where camera is not there. And then you want a camera. And if you have come across the history of this mobile phone development, you can see that maybe around 2000 or 2001 or those period, it was only the black and white mobile or so, color mobile with very limited features, no camera. And nowadays, people are using camera with the mobile phones.
Yes,
Now, so what is needed? That the user may ask for more and more features. Either user may ask or developer can think of, which may be useful by the users. And then if there is no provisions for future, that means we are not keeping any memory free where we can put our extra additional codes which may be required for introducing new features or so, then the earlier development or the current development which we are having will be completely useless and obsoleted. Then what you need to do same thing or same redesign from the scratch. Okay. And
yes.
so again, you will be incurring the development cost, extra additional development cost. And so that should be put into your product price, and then your product price will be high. So thinking all these or taking care of all these, we need to meet. So even so that means that what does it mean as an embedded system design engineer? That whenever we'll be deciding about the memory size, deciding about the processor, we should keep in mind this one also, these augmentations of feature in future. And therefore, we should always have some balance or margin in our design, so that maybe within next 5 years or so, we can introduce new features with the same circuit, same design, only adding that particular means the hardware corresponding to that particular features. Is it understood?
Yes, sir.
Yes, sir.
Okay. So now, as I said, this is real-time operating system. Now, I ask this question that what is real-time system? So I have given two examples. System 1, which takes 1 day to predict the next 3 days weather ahead. Okay. And another system which trips a relay in 1 microsecond after a fault occurs. All of you know relay, about relay?
No,
No,
sir.
sir.
Yes, sir.
No. Okay. In your home, have you seen fuse?
Yes, sir.
What is its use?
So during any voltage fluctuations, it helps. Means if high voltage come, it gets stripped down, and our home appliances gets it.
So actually your voltage doesn't go higher all the time. Rather current may go
Current.
higher. Okay. And so the fuse is related to current principle. So if it is higher, then it will be molten, right? So disconnected. So nowadays this fuse is replaced by what is called MCB,
Yes, sir.
circuit breaker, circuit breaker. So whenever there is a short circuit, have you experienced that? That MCB gets stripped, means is off,
Yes, sir.
becomes off.
Yes.
Yes, sir.
Yes.
Okay. So
Goes
relay is
down.
something like that. Relay is something like that only. So it requires, means this relay must be very fast operated. Otherwise, the system may get damaged. Right. And so a system, you have developed a system where the current is measured, and as soon as it is going beyond certain limit, it is tripping the relay, and that happens within the 1 microsecond of that fault. And the first system, say about the weather condition prediction, you have developed a software which is getting executed in your computer or so. That is also a kind of embedded system utilizing the processor. And then it takes 1 day time, and then it predicts what will be the weather in next 3 days, next 3 days. Okay. Am I audible?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
So after next means, so which one in your opinion is the real-time system? Any guess from anyone?
The system 2.
System 2.
Yes, sir. With relay.
So everybody is agreeing?
Yes, sir.
Yes, sir.
Now my question is, why you think so? Is it because that it is operating within microsecond order?
Sir, because it is able to give us the result then and there in real time.
And you think that the system 1 is not giving us?
Like, but it is not giving in real time. It takes like 1 day to predict, so it is not real time. So like for example, if we give the input today, then it will give after 24 hours, so it is not real time.
So now Let us see the answer. So answer is both a real-time system. Now, why this is so? So the real-time system does not depend on the observer. Now you were the observer, but the user who uses it. Okay. Now let us explain it. The first system, the user is human being, but what is the this utility of that prediction? So 3 days ahead it will predict. Now even if it take 1 day, it doesn't matter to us because we are gaining the predictions 3 days before it's supposed to happen, right? So for example, as a common people, we are not measuring this, but it is measured in the meteorological department and then in radio or televisions or so, or social media, it is circulated 3 days ahead that next coming 3 days, this will be the weather. Is it not usable, this information? This is usable, definitely, because based on that, we can plan our next 3 days activities. Okay. And so even if it is taking 1 day time, it will not hamper the overall performance of the user or user requirement. And in second case also, the user of the system is the device attached to that relay. And since those equipments cannot compromise any delay beyond this 1 microsecond, so it should be within that. And so in short, or in a summary, what a real-time system is a system that is executed within an affordable time limit. Now, this time limit is given by the user of the system. Sorry, by the user of the system. Not by the developer, not by the value of the execution time. Is it understood?
Yes, sir.
Okay. So I think you should not forget for rest of your life that real-time system doesn't mean that it should always be executed within a fraction of a second. It completely depends on the user's constraint, user's utility. Okay. And to summarize what we have learned within this week, that the task on the embedded system we can carry out the user interactions through keyboard, 7-segment LEDs, then LCDs or in any other such types. Then we can do some signal processing using the help of this ADC, DAC as interface. Then we can develop the filters, different signal transform we can carry out. We can also think of signal communication, different way of communicating the informations or data. Parallel, serial will be means learning those also gradually. And then we found that we should have a design goal. And in short, this is our output must be accurate and precise, and that should be within tolerance limit. The accurate and precise, by this particular word, again, this tolerance limit is given by the user. Okay. So that's why even if some output may be inaccurate, but if it is within tolerance limit, we can utilize that. Okay, then we can use these optimum resources utilizations, then real-time operations we need to do, and again this is given by the user. So all this goal with respect to, it should meet with respect to user, and alternatively we call it as a customer or client or so. Okay, so today we stop here, and next week onwards we'll try to learn the 8085 or 8051 and its different features.